All right. Well, good morning, good afternoon. This is Jason here with LMGI. Um, just a little reminder that you are all muted, so feel free to heckle me. I won't be able to hear it. Today, we're going to continue with the Solid Edge 2020 portfolio, talking about what's new. Really nice release, a lot of excitement around it. The community that I frequent, the Solid Edge community, reflects a lot of interest, a lot of people jumping on very early. Just released a couple of days ago. Um, Big changes in electrical and motion simulation. Today we're going to talk a little bit about the brand new 2D nesting application, and also a little bit what's new in the CAM, or computer aided manufacturing area. I'll show you a little bit about that. So nesting, brand new. We've had some requests for this over the years, and we always had to defer to other software vendors. Now the Siemens guys have written their own 2D nesting. This is just kind of a goofy slide on some examples of things that any sheet type products. Of course, the challenge is when the number of parts gets high and the shapes get complex, it can be too difficult to do manually. So this is a brand new product. I'm amazed at how complete it is. Actually, it seems to be really good. It is a standalone program. It does use Solid Edge when you convert existing Solid Edge models, but you can just work with DXFs if you want. It does. It doesn't. You'll see in the demonstration. It's basically standalone. So it can automatically go in there and find your flat patterns, and then it has an algorithm for generating the most optimal use of your material. So it uses kind of a, I don't know if you'd call it like a brute force algorithm, maybe, where they, continuously tries to improve on the last pass, and eventually it will kind of level off. You'll see. So the ROI, return on investment, this could be substantial. You really have to run your own numbers to see, what's your material costs. Maybe you're a yacht maker where you use a lot of very expensive exotic plywood. Maybe you make metal parts, and stainless steel is very expensive per sheet. Think about how much you throw away. So this is an add-on application. Doesn't come with even premium, unfortunately. But really, in my mind, it's a matter of, can you save a lot more money than the cost of the software? That's really what it's all about. And I think that's true, actually, from what I've seen, if you have the application for it. So yeah, I won't spend too much time on these slides. Nest inside openings. So if you have, a part with a big hole in the middle, it knows to utilize that material. You have angular control. You can make use of tailings or leftover pieces of material. And who might use it? A programmer, obviously, if you have your own in-house water jet or laser or punch, whatever type of process that you use to cut your sheet goods. Could be a costing person, could be a purchasing agent, so they know how much material to purchase. So I'm going to jump right into a little demonstration here so we can see what that looks like in the software. I'm going to start with we call it our hero model. And you might want to find out what you're dealing with your sheet metal parts. Where are my sheet metal parts? I just thought I'd throw this query in here. It's a great way to select all my stainless parts and get them in the select set so that I can just show only those. So just using the isolate just to kind of, show off some of the newish things in the software. In fact, I just have a display configuration that I can apply anyway. But this is essentially all the sheet metal parts that we need to manufacture for this design. And at this point, I'm just going to launch Solid Edge 2D nesting. And you'll see the user interface is very, modern and not too different from Solid Edge, I guess, though it is a completely different package. So you can create a new project, you can open existing projects that have already been nested, or if you want to work on them more for whatever reason. But to create a new project, you can just simply browse out to your Solid Edge sheet metal ore parts. It will also extract blank bodies, if you know what that is. So it goes in there and finds those flat patterns. Takes a little while to process. It is in the background kind of using Solid Edge to open and extract that flat pattern. It's just kind of grunt work on the computer's side, and then it lists them all out for you. You've got a little legend at the bottom that just explains what the colorization is all about. Anything orange is suspect. I think this first one has a very sharp, that's probably a bad design anyway, but if even with a water jet, that probably wouldn't be awesome. We could just remove that one and not process it. This one has kind of a chamfer that was done, so there's not really a clear boundary, so we could just take that right out. And this just has like a relief, so that's probably okay if we're using a laser, or so it just flags those, identifies them as possible problems. So here's your kind of a grid. There's a couple of grid views. I guess I'm just going to show you the one. You can bring in DXFs. This is just an example, of bringing in some extra DXFs and set the quantity. So yeah, so this allowable rotation is kind of like saying it's okay if this part is put on the sheet at 90 degrees or 180 degrees, maybe there's no grain pattern and there's no brush material, that kind of thing. So you're allowing it to rotate a particular amount. You can manually set the quantities as I'm doing here. Pretty easy because you can sort and you can fence and you can do them in bulk. It's really pretty easy. But you can also bring in a CSV file that could be populated from another system, other shapes or CSV, and that can also drive your quantities. So you may have an MRP system that's kind of driving quantities, and you could bring that data in from there so you wouldn't be worried about fat fingering the wrong number. Your sheets, of course, they could be whatever standard sheets you can have as many as you want. It's basically the raw material sheet size. And then we go to the actual nesting. I'll kick this off, but I didn't show you how you can rotate. You can rotate individual pieces. There was the allowable rotation, which will kind of let it put it wherever, but if you want to pin it to a particular rotation, you can do that as well. So you see this just kind of is processing. That's what the little chart is showing. It's running kind of permutations, or it's iterating on different scenarios through this kind of a brute force, just trying all these different possible arrangements. There's a variety of settings you can experiment with. You see like efficiency, prefer repeats. I don't know. Probably would take a little experimentation to really get to know it. Of course, there's documentation. And what's kind of nice is you're not stuck with just the last one that it thinks is the best. You can kind of pick one of these that you think maybe you want a tailing of a certain way, or maybe you have some reason where you think one of these is a little better. You can export it back to Solid Edge. and send it on and work with it in a CAM system, or you can output it to your external system in a, AutoCAD format. Quite a few settings there. I'm sure you can get what you want. Summary, this detailed report, I really like this. This seems like it would be really useful for the guys actually doing the work out there. They'd have a really good idea of what they should expect to see being, output from each of those sheet goods. And if there were any issues with it, they would, might maybe flag it, or so. It's just good information sharing with the reporting. So if I open an existing one, I thought this would be fun to show. I just grab some arbitrary one of these shapes and I say, I want to use that as my template, just to illustrate that you can use these odd shapes as the material that you want to try to nest these parts into. So if you do have some waste material from an old job or something and you really want to utilize that, this will allow you to do it. I just thought that was really cool. Pretty amazing algorithm going on there. So that's 2D nesting. If you have any interest in it, I really encourage you to give us a call. We'd love to show it to you live, and maybe try it with some of your parts, and you can tell us what kind of challenges you might need to. Maybe it's the material has a brush finish on it or something like that. So now a little bit of CAM. CAM is my favorite. I used to be an NC programmer. And so with CAM, we're talking about the marketing refers to it as Solid Edge CAM Pro. It does launch right from Solid Edge. It's essentially the NX platform, which is, been around for a long time. So it's very robust. It's very mature is the word I was looking for. But it's continuing to evolve. The dialogues, they've changed recently, which is something that I really love. If you've never seen NX, this probably doesn't mean too much to you, but NX has an extremely configurable platform, even down to the input panels. You can even customize those. So this is kind of a new layout that they've provided. Adaptive milling is fairly new, and in the latest version of NX, they've improved it even more. This is a high-speed milling, it's a high-speed clearing type operation, not for finishing. It's for just getting the bulk of the material out. It's geared towards high temperature alloys or your titaniums. That's really where it excels, but you can use it for anything you want. Actually, it comes with any CAM that has even the 2.5 axis package comes with. So that's really nice. It's part of their rough milling kind of module. It's part of cavity milling basically. So it's been improved quite a bit. I'll show you that in the demonstration. More improvements on, say, spiral finishing. I won't go too deep into some of these. You can always, give us a call or check out the replay. This is nice. You can combine operations, so it kind of behaves as one continuous path. So you don't have these retracts and re-engages. It just kind of cuts it all. Considers it one type operation. There's benefits there. And for creating a post, it got even easier. There is the included post builder, which has always been there and will still be maintained, but they've got a new post configurator, which is kind of a very user-friendly. Pick from the options, pick the drop lists, and you get a post very quickly. So it can be very easy to use, but it can also be customized as well. Improvements in visualization. You can now just touch right up on the main ribbon. I'll show you a little of this in the demonstration. You can turn on the ability to just touch an element in the toolpath. The tool will jump to that point. It's just faster. We've always had really good visualization of the machining in NX, but it's just gotten to be more accessible and faster. And in Solid Edge 2019, you might have noticed they added the pitch when you make a hole, and that was another column that was added to the Excel spreadsheet. So one of the reasons they did that is when they hand off the parts to CAM, the CAM system now can be more sure that that's the correct tap for that hole. Without that pitch information, say a half 13 or a half 20, it might be a little unclear what tap they should really apply. So that has been added for that reason. Part of the feature recognition. So let's take a look at that. Starting in Solid Edge, I'll launch my Cam Pro. And you can also start in Cam Pro or NX. You don't have to have Solid Edge on the system, which is kind of nice. People sometimes want one application, but you don't have to consume a Solid Edge license to use your NX Cam, which is kind of cool. So I'm just gonna, in this case, I launched it from Solid Edge. But so we're gonna, I might set the background at some point, but we're going to initialize for machining, and this is kind of like in Solid Edge when you do File New and you pick a drawing template. It's got all your standard stuff in it, you know. So this has all your standard machining stuff, like you could have tools or fixtures or whatever you want in that template. That's really all that step is that I just did. So I'll make the background a little nicer here. And then it's really a matter of just setting where the 0 should be for your machine tool, where you expect the user to tell the machine that's where the 0 is. Pretty easy manipulator. And then we just specify the part and the blank. Anybody that follows CAM has probably seen this a million times. The blank, NX has a really nice set of tools. You can pick a piece of geometry like that plate, or you can do a part outline. So you don't actually have to model up something. So that's going to be just as if the perimeter were cut first. So we set the material. I might just turn that plate off so it won't clutter up our display too much. And now I want to show you the recognition. This is actually really cool. Find features. So this uses feature recognition, which comes with the 2.5 axis and up. And you just kind of specify a direction that the tool will approach, and it's going to go find features for you. There's a large number of features out of the box that it will identify. Holes are very easy. That's low-hanging fruit. But it'll also find many pocket shapes and slots and things like that. Think of it as just kind of doing all the picking for you. And you can see it's identified those. And then you simply say, I would like to apply a machining process to that, which means drilling and tapping and milling. And it will go and find the tools that are appropriate for those features, or at least the ones that it will work. You can always change them after, which is what I really like. This is all just kind of out of the box technology here. This system is actually really powerful. It can be trained to recognize things the way you want. You might have specialized parts, or you may you have a certain process that you cut them with. You can teach it to use your process, but you see it created these geometry parents, we call them. And then under it, you put the operation, and then it just cuts those areas with those either rough milling or cavity milling. There's a spot drilling and a regular drilling, things like that. So we'll just generate that out. So generate is the creation of the actual tool path once you've defined enough. So you can see how with very little input, you can get a program output very quickly. So you're probably thinking, well, that's not the way I cut that part, but remember, you can teach this system. So this is the standard verification right here. This has been in the software forever, material removal or just a wireframe verification. So this is really nothing new. It's very good verification. But later I'll show you now. So this is the select tool path. So this is like very quickly, you can just pick on a toolpath entity, and you can do a play from there. You can even turn on the IPW is in-process workpiece. That blotchiness is just because there's a part turned on. If you hide the part, it looks perfectly clear. It's just kind of a computer graphics thing. You've probably seen that before, but you've got kind of a piece of material on top of a part. So maybe I'll get rid of this and do an adaptive milling just so you can see how easy it is to create one manually. This would be the steps to create a manual operation. I don't know what tool I could browse. I think I'll probably just make one from scratch. Yeah, I'll just make one. So I'm going to create the operation, and and then I'll kind of make the tool on the fly. This is cool. You can, even after you've started the operation, you can edit or you can create a tool and put it in pocket 8. I'll just kind of leave the defaults of 1-inch end mill. So it kind of created that on the fly. It might have been a little confusing with this, but this is your main adaptive milling panel, and it has everything you need right up the step over, and just do a quick generate on that. You can see it's creating the passes. So the adaptive path is a very kind of, I just want to call it a swoopy path, but it gives you a consistent chip load on your tool, which allows you to go much faster, higher RPMs, more fluid engagement. Getting widely accepted in the industry as a great way to clear material. So there you go. So that's adaptive milling, NX Cam Pro. Oh yeah, the dialogue. So this is an example of customization of the dialogues. Just convert that to this new Explorer view. I love this. I think I would probably just have it automatically convert all my dialogues to this view. What I like about it is, you know, there's a lot of settings in CAM because there's a lot of ways that people like to cut parts, and it gives you access to them very quickly. And you can kind of poke around and look and change different tools and try some things. Like I might want to change my tool diameter once I generate it. I think I probably should have used a smaller tool so it gets into the corners better. And you can just generate it right from this panel and get your immediate feedback, immediate gratification. And it's much more productive, I think. It's having it all on one dialogue. And then here is the full replay again, just to see the difference between the, still probably could go with a little bit smaller tool, like maybe a 1/2-inch end mill. And that's about it. So there you go, NX Cam. By the way, NX has started with this continuous release process, which is kind of neat, a little bit like Windows 10. There is no Windows 11, you know, they're just going to update and update and update. So Siemens decided to do the same with NX. It's not for Solid Edge, but just for NX. You can decide when you want to adopt the new release, but it's going to make it a lot. It's going to make it a lot easier to move ahead and stay with the most current functionality in the software. So it's actually a really good thing. It's just different from what we are used to, I think. So with that, I guess if there are any questions, we're at, I don't know, 25 minutes. Let's see any questions come in. I definitely expect questions about pricing. It's probably a little early to talk about pricing for the nesting, but it's very competitive. And the fact that it can run standalone actually has good value. So I guess I would just encourage anyone interested in CAM or the nesting, give us a call here at LMGI, or you know, reach out to us in some way. So there we go. I hope everybody has a good afternoon, and thanks for attending.